Alright, people, more on solving linear inequalities. Now, we did a little bit of work of just solving regular inequalities, and we're going to go an extra step this time. So now we need to solve, we need to graph, and we need to write it in interval notation. And what better way than start it off than by an example. So, I have 5x minus 3 times 2x minus 1. That is greater than equal to 2 times x minus 3. So first things first, we must distribute the negative 3 to everything in the parentheses to the right. So that gives me 5x minus 6x plus 3, which is greater than equal to, now we must distribute this 2 to everything to the parentheses to its right, which now is 2x minus 6. Before we go any further, we must at least combine our like terms, which is the 5 minus 6x, which will give me a negative x plus 3, which is greater than equal to 2x minus 6. I always like to move my x's again to the left-hand side, so it doesn't matter which way you go. Subtract the 2x from both sides. These cancel out, which now leaves me with negative 3x plus 3, which is greater than equal to negative 6. So we must subtract the 3 from both sides when solving, and I am now left with negative 3x greater than equal to negative 9. What the class loves to do is divide these lovely things by negative 3. Now, again, when you divide by a negative sign, you must flip the inequality. So this will now leave me with x is less than equal to positive 3, because remember, two negatives make a positive. Now we need to graph this lovely thing. So I set up a number line where this will be 0, this is 1, this is 2, this is 3. So according to the inequality, it is less than equal to, right? So that means I am a closed interval at 3, and I shade everything to its left. Now the next part of the solution, we also say that we need to write it in interval notation. So where does the graph start at? Well, the graph is starting at where? Negative infinity. And where is it ending at? It's ending at positive 3. So my interval notation would be negative 3. Remember, we cannot put a bracket around it. Oh, did I say negative 3? It starts at negative infinity. Again, we cannot put a bracket around negative infinity because we cannot bound down bound it down. Sorry. And then we stop at positive 3, and then it is a bracket because it is closed at 3. All right, so that's one down, a couple more to go. Now, one more thing before we keep going into compound inequalities, let's do a fraction, the things you love to hate. So I have 1/2 x minus 1/3, which is greater than 2/3. So the first things first, just like I taught in class, we have to find the LCD. Well, what's our LCD in this case? Well, you can do one or two ways. You can multiply the two denominators, the two numbers, which is 2 times 3, which will give you 6, or you can see what number they both multiply, the lowest number they both multiply to, which is 6. So now that the LCD is 6, we multiply everything by 6. Why? Because we want to get rid of fractions. I hate fractions just as much as you do. So 6 times 1/2 x plus 6 times negative 1/3, which is greater than 6 times 2/3, Well, 2 can go into 6 3 times, so that leaves you with 3 times x, or just 3x. 3 can go into 6 how many times? 2, so that leaves you with 2 times negative 1, so that just gives you a minus 2. Greater than, well, 3 can go into 6 again 2 times, and then I'm left with that 2, so it's 2 times 2, which is 4. So now what's left to do is to just solve for the inequality. So add the 2 to both sides, and then we are left with 3x, which is greater than 4, 5, 6. So now divide each side by 3, and x is greater than 2. So can I graph this solution? I surely should be able to. If this is 0, then we have 1, then we have 2. It is open, and since the greater sign shades everything to its right. How do you write it in interval notation? Well, since it's open, that means it is a parentheses, and then what? Goes to infinity. So, that seems pretty simple to do. Now, for the funner stuff. Compound inequalities. Compound inequalities. So we'll start off something maybe simple. If I have negative 10, which is less than 2x, which is less than 20. When we're solving for compound inequalities, or 3 parts, okay, it's the same way that you would solve for a regular inequality or a regular linear equation. So whatever you do to one side, now you must just do to all 3 sides. So I divide this by 2, I would divide this by 2, and I would divide this by 2. So 2 divided by negative 10 gives you a negative 5, which is less than, these 2's cancel out, which gives me x, and then this becomes 10. Simple, right? And then we surely know how to graph that from doing it in class. If this is 0, this is negative 5, and this is positive 10. We are open here, and we are open here, and we shade everything in between. Okay?